Yes, welcome back to our online class. We have discussed force on a current carrying conductor and we have solved some problems on that. And now today we are discussing force on a charge and we're also discussing the motion of the charge because you discover that the charge or the current moves, in the fields, the direction of, we discussed the direction of current. It means the current flows. So we're also going to discuss and as it flows with a certain velocity. So here we are going to look for how to calculate the force on that charge and also at the same time how to calculate the velocity. Now, anytime you are given a question on force on a charge, you have to know that the formula is force on a charge F equals QVB, all in newtons. Where Q is the charge, V is the velocity, and B is the flux density. Now, let's take an example here. We have to calculate the force exerted on a charge of 2 multiplied by 10 raised to the power of negative 18 coulombs traveling at 2 multiplied by 10 raised to the power 6 meter per second. So that's the velocity of that charge perpendicular to a field density of 2 multiplied by 10 raised to the power minus 7 Tesla. Now, like I told you, it's very easy to do. Set values, then you know that F equals what? Q multiplied by what? The velocity multiplied by the flux density. Now, if I bring out my parameters, I know that my force is what? 2 multiplied by 10 to the power minus 18. So, my force is my charge is 2 multiplied by 10 to the power minus 18. 2 multiplied by 10 to the power minus 18 multiplied by the velocity is 2 multiplied by 10 raised to the power 6. 2 multiplied by 10 raised to the power 6 multiplied by my density, that's the flux density of field density, 2 multiplied by 10 raised to the power minus 7. If I solve this, I'm going to get my force F of this charge, the force on that charge, to be 8 multiplied by 10 raised to the power negative 19 Newton. And that is the answer. Now, let us calculate the velocity in this question. If you are given another question of this nature that you have to determine the speed of a 10 raised to the power negative 19 coulombs charge traveling perpendicular to a field of flux density 10 raised to the power minus 7 Tesla, if the force on the charge is 10 raised to the power negative 20 Newton. The same thing I told you, that you know that your force is the charge multiplied by the velocity multiplied by what? The field of flux density. Now from here, my parameters are given. The only thing I'm to calculate is what? My speed, that's the velocity. If I make speed the subject of the formula, I'm going to have V to be equal to the force divided by the charge multiplied by what? Field density. And if I put my values, I know that my force is 10 raised to the power negative 20, 10 raised to the power negative 20 divided by the charge here is what? 10 raised to the power negative 19, and the flux density is what? In Tesla, 10 raised to the power negative 7. If I should solve that with my calculator, I'm going to get the speed to be 10 raised to the power 6 meter per second. And that is the answer. Remember, the deal is that you must be happy, I must be happy, and we must be happy. So, do so well. Like, subscribe, comment, and share. Thank you.